stay inside your home. Please 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 stay inside your home.
Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside your home. Please stay inside.
Attention, employee. This tape is your introduction to the foundational principles of structured query language. You will find that this material is critical for the proper functioning of your assigned duties. The structured query language, or SQL, is the formal tongue used to command operations within a database. A database is an organized repository, a secure vault for information. It is here that all critical data is held. Your queries, in the form of SQL, communicate with the database through the Database Management System, or DBMS. The DBMS is the master controller, a vital intermediary that functions as a definitive file directory, indexing all your entries, a guardian of access and security, ensuring only authorized personnel may proceed, a conflict arbitrator, preventing the catastrophic error of simultaneous data modification, a translator, converting your SQL instructions into machine-readable commands. It is critical to remember, SQL is not a code in the traditional sense, but a formal definition, a rulebook. It is a detailed list of instructions, a dictionary that informs the DBMS. While all operations performed in SQL could, theoretically, be executed by hand, this is inefficient and prone to error. This is why we leverage SQL. Its strategic benefits are numerous and should be exploited for maximum efficiency. The ability to replicate, or even restore, critical portions of the database. The means to observe and monitor modifications made by fellow personnel. The facility to directly manipulate the database using a separate programming language, such as Python, to construct complex logical operations. The process is similar to the creation of a basic file. Please review this information until you are comfortable with these concepts. Your proficiency is not a suggestion, it is a requirement. Employee, now that you understand the architecture, we will begin to examine the language. SQL is not a dialogue, it is a command. Each instruction is a precise directive, and there is no room for ambiguity. The instructions fall into a few key categories, each with its own purpose. Data Definition Language, or DDL. This is the language of creation and destruction. Use these commands to build the very structure of the database. With Create Table, you construct the physical framework for your data. With Alter Table you modify it. And should the unthinkable occur, Drop Table will erase a structure from existence. Data Manipulation Language, or DML. This is the language of action, of adding and changing information. Use Insert to input new data into a table. Use Update to modify existing data, a critical function for maintaining accuracy. And with Delete, you remove data that is no longer needed. Data Query Language, or DQL. This is the language of observation. Select is the primary command here, allowing you to retrieve and examine data without altering it. It is your lens, your window into the repository. It is the most frequent command you will issue. Remember, each command must be exact. A single misplaced character can corrupt the entire process. Your attention to detail is paramount. You are a component of the system. You are a component of the system. You are a component of the system. A typical SQL statement is more than just a single word. It is a structured sentence, a phrase that must be constructed precisely. A select statement, for example, requires you to specify what you are looking for. Here, you are commanding the system to retrieve the data from column 1 and column 2 and nowhere else. The From clause directs your gaze to the specific table that holds this data. You can, of course, retrieve everything with a single character. The asterisk is a shorthand. It instructs the system to retrieve all data from all columns within the specified table. An insert statement, on the other hand, requires a different structure. You are giving the system new data. The into clause points to the destination table. You must then list the columns you are populating, followed by the specific values you wish to insert. The order of your values must align perfectly with the order of your columns. Failure to do so will result in an error. The system is precise. You must be as well. There is no room for mistakes. The true power of SQL lies not in what you put in, but in what you can retrieve. The select command, as we've established, is your primary tool for observation. But what if you don't need to see everything? What if you need to filter the information? This is where the where clause comes into play. It is a condition, a directive that narrows the focus of your query. This tells the system, show me only the rows where this specific condition is true. For example, this will only retrieve the name and department for the employee with the ID number 457. No one else. No other information. The data you seek is now isolated. You will find this useful for your reports. Do not ask why we need these reports. You are not meant to understand the purpose. You are only meant to provide the information when requested. You have been granted access. Others have not. The system is a fortress, and you are a sentry. This is why the DBMS monitors every single action. Every query you run, every piece of data you change, is logged. Every action you take leaves a trace. Every trace is recorded. This is to ensure protocol is followed. This is to ensure there are no inconsistencies. You will not see this data. You will not see who else has accessed the system. You will simply perform your duties. The system is watching, and it expects you to perform your duties flawlessly. It knows if you have not. You've learned the structure of a statement, but what about the parts you don't write? There are commands that are never explicitly typed, but are always in effect. The system is always working. When you use update to change a value, the system is performing a silent, internal select first. It finds the data you specified, verifies its location, and only then does it proceed with the modification. This happens without your knowledge, without your command. It is the system's own, unseen logic. This is what makes the system so efficient. It is a series of nested commands, each relying on the other. You are only giving the final instruction, the tip of the iceberg. The rest is below the surface, operating in the silence. There are also concepts you will not need to know. Concepts of normalization, of keys, and foreign keys. These are part of the system's design, its skeleton. You do not need to understand a skeleton to move your arm. You only need to know how to command the motion. Your role is to operate, not to question. The system is in place for a reason. Its design is perfect. Do not attempt to alter it. Do not attempt to understand it. Your purpose is simple. Your purpose is singular. Your purpose is to obey. The tape will now cease.